Welcome back and thank you for watching. Today we're going to talk about the quadratic formula. The quadratic formula is a very useful formula in helping solve quadratic functions. We have talked about many different ways to solve quadratic functions, and the quadratic formula is one of the most convenient ways, and the reason it is because it is simply a plugging in type of solution, and it works every time. And that's something to keep in mind when you're looking for ways to solve quadratics that you think are unsolvable. Alright, so we're going to leave the exploration as a warm-up to tomorrow at the beginning of class, but you're going to have to see how each step of the quadratic formula is derived from the original standard form of a quadratic function. Likewise, exploration 2 is mainly going to be done tomorrow in class as well. However, right now, so that we don't have a lot of downtime, I'd like to solve A and B to give you a good idea of how to use the quadratic formula effectively. I'll begin by writing it in above so that we have that as our guide. Opposite of B plus or minus the square root of B squared minus 4AC. That's known as the discriminant. We're going to get to that in just a little bit. All over 2A. Alright, so what I'm going to do first, and what I like to do always, is identify A, B, and C in the standard form of my quadratic function. So that's 1, -4, and 3. Now I'm going to simply plug it in to the existing quadratic formula. The opposite of -4 is +4, so that's 4 plus or minus. The square root, well, -4 squared is 16. Minus 4 times 1 times 3, all over 2 times 1. Where I like to go first is I like to simplify the discriminant before moving on. So I'm going to rewrite everything except the discriminant, which simplifies this time to 4. Divide that by 2, and now I'm going to simplify everything down. So I get 4 plus or minus 2 divided by 2. And now I solve each one using the plus, then the minus to get my two solutions. So 4 plus 2 is 6. 6 divided by 2 is 3. 4 minus 2 is 2. 2 divided by 2 is 1. So the two solutions I get here are 3 and 1. Alright, now I'm going to go over here to answer B. And it's going to be A equals 1, B equals -2, C equals 2. I'm going to plug into my quadratic formula 2 plus or minus 4 minus 4 times 1 times 2 divided by 2 times 1. I'm going to simplify the discriminant first, and that's going to give me -4. So I get 2 plus or minus the square root of -4 divided by 2. Now what I'm going to do is I'm going to simplify the -4 even further. I'm going to go 2 plus or minus I times the square root of 4 divided by 2. 2 plus or minus 2I divided by 2. I'm going to look at the GCF of these three numbers, and that's how I'm going to simplify my expression to its final form. X equals 1 plus or minus I is my final exact answer. Can't combine this down anymore, so I'm going to leave it just like that. So this is the way that you're going to apply the quadratic formula when solving quadratic functions that are in standard form. Go down to the bottom of this page and we'll talk about these two problems, or these two writing prompts down below. Okay? Alright, I want to take a look at question number 3 because it's a little bit tricky, but what you need to do here is, when you need to derive a general formula for solving a quadratic equation, You just need to use coefficients a, b, and c, complete the square, and solve for x. Question number 4 is the one that's most important to me. I want to know what it is that you think about each one of these 5 methods that we've learned so far for solving them. So what I'd like you to do is I'd like you to summarize each of the 5 methods in the space below. You're going to talk with your group mates about this tomorrow, so please take some time to think through this tonight so you have a clear understanding of what you want to say to them and what it is that you want to explain. Then what I'd like you to do is place a star next to your preferred methods for solving quadratic equation. And then I'd like you to analyze and think about the methods that work most frequently and circle those. We'll see what kind of problems you come up with, what kind of answers you have to this particular question, and what questions you still have about it. All right? All right, so take some time now, pause the video, and before moving on, and have some well thought out summaries for each one of those. All right, what we're going to do next is we're going to talk about our vocabulary for this particular video. The first one is the quadratic formula. That is the method for solving a quadratic equation, and it works every time. So if you didn't put a circle around that one, you probably should go back and circle it right now. I'm going to go ahead, just for sake of remembering, I'm going to write that through one more time so that we have a clear idea of what this quadratic formula is. There it is. All right, the discriminant is the radicand of the quadratic formula, and it determines the number and types of solutions a quadratic equation will have. So here is the value of the discriminant, b squared minus 4ac. If it's positive, it's 2 real solutions. If it's 0, it's 1 real solution. If it's negative, it'll be 2 imaginary solutions. All right, so please remember that table. It's going to be very helpful for you when you're looking at the solutions to a quadratic function. All right, and one more time, you'll see that the quadratic formula is written for you there. And there's one little set of notes that I'd like you to add in there. It's important that you solve this in stages. You can't just type this in your calculator and solve it in one step. So as I suggested earlier, simplify the discriminant, then simplify the radical, and then finally look for a GCF of the 3 terms on the outside of the radical. The radicand does not count when looking for a GCF, just the numbers outside. All right, we'll take a couple of examples here before I let you solve the rest of this, the rest of these problems on your own. Here is a graphical version of the table that I set up earlier, helping you analyze the discriminant even further. So you can take a look at what each of them means when it comes to the value of the discriminant. And we'll do a couple of examples from here. I would strongly suggest that you do a couple more on your own, and then we'll use the rest of our practice problems tomorrow in class, and this will help us get to where we need to be. So remember, before we get started here, we need to have the quadratic formula readily available and at hand. So I'm going to go ahead and write that one more time. B squared minus 4ac all over 2a. And then I've got to remember that I'm working in standard form. This is not in standard form, so I'm going to go ahead and change it to standard form. That's w squared minus 4w plus 1 equals 0. Just move those two to the same side as w squared, and now we're ready to go. Identify a, b, and c, and we will simply substitute after that. So that's going to be 4 plus or minus the square root of 16 minus 4 times 1 times 1. That's going to give me 2 times a. So that's going to give me 12 inside, so it's 4 plus or minus the square root of 12 over 2. Simplify the 12. That's going to be 3 and 4, because 4 is a perfect square. So now I get 4 plus or minus 2 square roots of 3 over 2. And here's what I was talking about with simplifying it down to using the GCF of the numbers on the outside of the radical. The GCF of these three terms is 2. So what's left after I divide that out, 2 divided by 2 is 1, 2 divided by 2 is 1, 4 divided by 2 is 2, is the solution in simplified exact form, 2 plus or minus the square root of 3. The last one I'd like to do with you is question number 6. So we'll take a look at this one. It says, use the discriminant of the quadratic equation to describe the number and types of solutions that this one will have. So it's not in standard form. So I'm going to do 4q squared minus 3q plus 1 equals 0. Square root of negative 3, which is 9 minus 4 times 4 times 1. So that's going to give me 9 minus 16, which is negative 7, and that will be 2 imaginary solutions. Helps if I can spell imaginary properly. The remainder of the worksheet's going to be for you to complete during class tomorrow, so please have this ready to go so that we can have some useful practice using the quadratic formula.